And that's what we get for our final answer. Again, every time we do these problems, we always have to have some form of construction of our equation and then some form of substitution using what they've asked us for. The next few lessons will always deal with that. You'll note that today's lesson talked about different compounding numbers. So I'm actually going to zoom in on this chart that I've put on the right side here. You're eventually going to take a look at this and see what comes up. So here's what we're going to do. So when we talk about the compound name, we have all these different terms. We have annual, and when you hear something that is compounded annually, all we're relating to is the number of times in a year. That something happens. So if it's annual, the compounding number is 1. If I have something that is semi-annual, that happens twice a year. If I have something that's quarterly, that happens 4 times a year. Now, the next biggest compounding number is monthly. And how many times does that happen? You guessed it, 12. The next one that we have is biweekly. But we'll hold off on that first. We'll go and write up how many times something happens if it's weekly. If something happens when it's weekly, it's 52. So now we can go back exactly one step. Bi-weekly basically happens every 2 weeks. So it doesn't happen every week like before. It happens every 2 weeks. So essentially we're dividing by 2. So we have 26 weeks. And then we have daily, which is 365. So all of these things relate to the number of times in a year that something happens. Now, for every one of the problems that we work with, let's take a look at this problem that we have here. We're always going to have to bring out our apron. The moment you see something that talks about compounding, you're always going to bring out your apron. An apron refers to the following: all the variables that are used in the future value, or the amount of a compounding interest. Basically, let's go over this problem and we'll see how we use it. Mr. S wants to put $2,000 into a GIC account that pays 7% semi-annually. Now, first of all, we need to create an equation. So we'll bring out our apron, and here's what we know. If we look at that $2,000, that $2,000 is either the A value or the P value, the amount or the principal. So we look at that problem. We have $2,000 that's being put into a bank account right now. So we're going to immediately say that is actually $2,000, and that represents the start value. So this represents P. The next thing we have to do is we have to figure out what the rate is. And essentially this is the rate. The rate R is going to be calculated as, well, 7, I always do this. I write 7 over 100, and I use my calculator to find my actual decimal percentage. Finally, this is the hard stuff. Anytime we talk about I, we have a specific equation that we use. We use R divided by the comp number. Now, the comp number is always tied to the comp name, which is semi-annually in this case. And if we go look at our chart over here, semi-annual means this happens twice a year, which means that this I value is 0.07 divided by 2. Now, I tend to leave this number as it is because sometimes these decimals don't come out nicely and you end up rounding. And in business, we tend not to want any rounding because when we round, we end up losing money in the end. But in this case, we'll do this just for this problem. The next problem is to figure out what n is. If something is compounded semi-annually, semi-annually means the number of times it happens within a certain number of years. So now we're going to actually write an equation for that. This is going to be years, so n is equal to the years, and then we times that by whatever the comp number is. Okay? So now, let's go to our equation because it says here in this problem, it says we have to create our basic equation. Apron helped us find all the variables that we need for this following equation. A is equal to P1 plus I to the n. So, we use our apron. Well, we don't know what A is, so we're going to leave A. We have P is 2,000. We have 1 plus I, which is, in this case, for this specific problem, comes out nicely for a decimal, so we'll just write 0.035. Raised to the n, and I'm going to leave n normally because right now I don't know what n is. And now what we'll do is we're going to calculate our final problem using our apron. So every time we know we've got a problem here, we're always going to start by setting up apron. We know that this is the problem and it happens after 15 years. So let's quickly set up apron and you'll see what our answer is. Now basically after we bring out our apron, we get the following. Now notice, n is equal to 15 times 2, which equals 30. So I always want to simplify what goes into my exponent. And then what I simply do is I substitute. And we get the following. In our basic equation, we start off with A is equal to P1 plus I to the n. And now we continue substituting directly, which is equal to 2,000 bracket 1 plus, well, I won't put in 0.035 that we had here. I'll actually put it how I expect to see it in most of your work. 0.07, and then we divide by 2. Whatever you get for the I value goes there, wherever I is. And then we substitute our 30. When you do your final calculation, you're going to get $5,613.59 as our final answer. So that is what A is equal to, and I'm just